Well, hopefully I've started this meetup here through GoToMeeting. I'm Ellis Hughes. If you don't know who I am one of the organizers of the Seattle Use R group. Um, I've been doing this for a few years now. I'm pretty excited about today's talk. I'm organizing this with Daniela, who isn't showing her video right now. But they're the ones that are helping facilitate this video screencast so we can all meet during this time of COVID, where we're all separated. Hopefully everybody's been taking their time and doing whatever they need to take care of themselves mentally. But now that we're a few months into this time, I thought we could start doing more meetups and start trying to get back to life as much as normal as we can get it to be at this time. So today's meetup, I'm sure a lot of you are excited about, is on R2D3, which is a package I created by one of my friends, Javier, at our studio, which is a way to interact with D3, which is a JavaScript library for creating pretty great visualizations. Integrate that into your R process and create really beautiful plots that are interactive, depending on your skills in JavaScript. So today's talkers are speakers is Helen Miller and Jason Taylor. So I work with both of them at Fred Hutch Cancer Research Center. They work in Rafael Guittardo's lab. Helen's been using, or actually, Helen, do you want to give a quick introduction about yourself?
Sure. Hi, everybody. I'm Helen. I've been using R for a few years now, and I actually started working with D3 when I was working at Mazama Science, which is also in Seattle. And at my position at Fred Hutch, I've been working on, finding more ways to create really cool data visualizations. And a lot of times it's kind of based around R, but I also work on a couple of different websites that are based around data and data visualization at Fred Hutch. And so I've been having I've had a really great time kind of figuring out how to incorporate, the really cool interactivity of JavaScript and D3 and using that with R. So yeah, I'm excited to talk to you guys a little bit about R2D3 and how you can, make really cool D3 plots in your existing R workflows.
Awesome, thank you. We're having a little bit of a technical difficulty right now unmuting our second speaker, Jason Taylor. So just give us a quick moment for that. Sorry, my two screens here, and it's just not working out for me. In the meantime, so Helen, is Jason going first with his slides?
Jason will be going first. Since he's not able to share, I'm just trying to get his materials set up on my computer so that I can share them.
It's all good. All right. In the meantime, so I guess I should mention, if you have any questions or comments, you can either raise your hand. I believe there's a button that you can raise your hand and I should be able to see who's raised your hand, or you can leave a comment in the chat or questions section, and we'll try to get to those as we can. While we're getting this set up, I guess I'll just put a plug in for, hey, we try to put on these meetings fairly regularly. We're trying to give you content that is valuable for you. So if you have an idea that you'd like to have shared, so like a topic that you'd like to have people talk about, let me know and I can try to find somebody that knows more about that. Or if you have an idea that you'd like to actually see presented, also reach out to me, because I really want to give all the R users in the Seattle area a platform to share what they're doing, because I know there's a lot of really cool stuff going on and it shouldn't stay behind closed doors. We should all be discussing it and sharing it and talking about it, because I love the R community and I love getting us all together. And if I can give you that platform, that'd be awesome for me. It just makes me feel good to make sure that you guys can present on that. All right, so.
All right, I think I'm ready to get started if you are, Jason and Ellis.
Let
me see.
Jason, can you talk? Apparently not. Here, Jason, why don't you try to call in? Or have you called in?
Is it possible for Helen to go first while Jason sorts out how he can get in?
Yeah, I could go. I could try and go first.
I guess they're kind of like they can go either way. Jason's gives a lot of background.
Mm-hmm.
But yeah, I mean, I guess we can get going on that. It's a good idea.
Yeah. So let's see. I will go ahead and start screen sharing. All right. So this is Jason's slides, and here are my slides.
There we go. We're seeing files. There we go.
You're seeing my slide that says "Bring the magic of D3 to R."
We are.
Yay! Okay. So we've gotten here at least. I think. So I'm going to go through kind of some ways to, yeah, as I said, kind of bring D3 into R and kind of incorporate it into our workflows. And Jason's part of the talk is diving a little bit more into D3 and how D3 works. So I guess for this point, just don't worry too much about what's going on behind the scenes like with D3 because we'll get to that in a minute. So let's see the pin. Oh, that's probably for Jason. So let's see. D3 is a really powerful tool which allows you to create, pretty much any kind of visualization you want. And these are interactive visualizations that you can, share over the web. But it really requires you to be able to load your data as a JavaScript object, and your platform has to be a web page. So I'm going to go through a few slides to kind of give you a little intro to how you can use this in R, and then I'm going to attempt to do a bit of a live demo. So R2D3, as we mentioned before, is an R package, which is developed by RStudio. And it's on Crayon, anyone can use it. And once you have that installed, you can have D3 plots like pretty much anywhere in your R workflows that you have HTML. So that could be our Markdown reports, that could be Shiny apps. You can even have these plots show up in your RStudio viewer or in a web browser. So this is kind of what it's all built around, is this R2D3 function, which takes two required arguments. The first one is your data, which is just an R object, and the second one is a path to wherever your D3 script is. And it really takes care of a lot of kind of more complicated things that you have to worry about when you're working with JavaScript that Jason is going to talk to you about a little bit more, and allows you to really just focus on, working with your data in R and then just creating the visualization. And so D3, of course, is a JavaScript library. So you will actually have to write some JavaScript. So you have this separate JavaScript file, and Jason will talk a little bit more about what that looks like. But R2D3 actually prepares some arguments for you so that you don't have to worry about, loading your data, which can actually be surprisingly difficult in JavaScript sometimes. SVG, so that's the container, and Jason will go a little bit more into what SVG is and how to build out your visualizations. But that's basically the element on the page that you're building the visualization inside of. And then just kind of figures out the height and width, which is another thing that you would usually have to set yourself. And you can pass in any other options you want through this options argument. So I'm going to show you what it looks like. So I'm hoping that now you can see my RStudio. And so, you know, the first thing obviously that you would do would be to, you know, create your D3 script. So actually, if you have R2D3 installed, there's a little option here integrated into RStudio to create a D3 script. And this is what it looks like. It just has this nice little template for you. And you might notice this preview button up here. Now it's going to want me to save it. I'll just call it demo. And this plot shows up in your viewer screen over here. So a little bit more about what's going on here. You might notice this preview tag at the top, and this will run this, and you'll see down in my console, this is the function that's run. It's that R2D3 function. This is the file that it's using, and it actually passes in some data up here as well. So I'm actually not going to go into what's actually going on in this code because Jason will dive a little bit more into that. But one thing I'll show you is you can, you know, change this. So like, I don't know, a lot of you might be familiar with the MT cars data set, which actually just comes with base R. And so if we want to look at like miles per gallon, and I'm going to actually just divide this by 100 because I don't want everything to go zooming off the edge of the page. And yeah, so this will just update our plot over here. And now we have this really beautiful, informative bar plot. Okay, so maybe sometimes you want to do something like a little bit different from the kind of default template that we have here. So I actually have this empty cars JavaScript file, which will create a scatter plot. And Jason will actually go a little bit more into detail about how this whole file works, so I'm not going to get too deep into it. But you can preview that. And here you can see I just said data is empty cars, and it makes this nice little scatter plot that shows up in your viewer. So there's a couple other options we have here. Once you have this in your viewer, if you want to share it, you could just save it as an image, you know, update your size, and it'll automatically update that for you. And then you can save it as, you know, PNG or whatever, so you can, you know, share it on Twitter with all your friends. Because, you know, this is a really beautiful little plot we got here. Another option, especially if you have like say interactivity built in, would be to save as a web page. And this will just create an HTML document which you can open in your browser. And this is just totally standalone, so you can share it with anybody, which is also really handy. Let's see, what else we got? So, oh, also I've added into this script here, there's, as I mentioned, you can pass in any options you want as an additional parameter. And I've actually added a handler in the JavaScript file for a color option. So if I just add here color, no, let's do this as list options. And you can add, you know, whatever color you want. And that'll update in our plot. Awesome. Sweet. So now these are like some ways that you can make standalone plots to either show up in your RStudio viewer, or you can save it as a static plot, which I don't know why you necessarily want to do that, because then you just use your regular R functions, or you can save it as a web page, especially if you add any like interactivity or anything. So what if you want to like incorporate this into a report or something? Well, there's some integrations also with R Markdown. So we look at this R Markdown file. The easiest way to do this is just with that R2D3 function. And that's just exactly the same. And I'll just render it to your page. There's also this like special D3 chunk option. And you just have to make sure you pass your data in. So this is just that exact same JavaScript code that I've copied right here. And that shows up just the same. So if I knit this thing, oh yeah, you get all these goodies showing up. Sweet, so that's like a really easy way. If you've created your D3 script, you can just add a nice little custom interactive plot into your art report. And then I think the way that, in my opinion, is the most powerful would be in a Shiny app, which is actually how I was first introduced to R2D3 because I wanted to add some extra interactivity to a Shiny app. So if you're not familiar with Shiny, it's our package, which allows you to create interactive web pages using R code. And this right here is a little demo app that I've come up with. And it's really simple. I'm just gonna, I guess, start off by showing you what it looks like, and then I'll go a little bit more into what's going on. So here's our app. Here's that same plot we were just looking at. And then we have some inputs over here. So you actually select the X and Y axis. So if we update this, we get these nice little transitions as our D3 plot updates, which is another D3 feature, are these smooth transitions. Oh, and then the other thing that I've added here is you can actually click on these points, and the name of the car that point is representing will show up below. Sweet. So yeah, that's one way that you can use it in a Shiny app. So I'm just going to go a little bit more into how all of that is working. This is like a super quick overview of how Shiny works. There's these two kind of main elements. We've got the UI element, and that defines everything you see on the page. You'll see here's those inputs for x-axis and y-axis. And then the outputs is that plot, the D3 plot, and that text about the model that you've clicked on. And then the other main part is the server. So this is just kind of like the engine that takes inputs from the users and then transforms that into some sort of output that'll show up on the page. So you may have noticed there's these D3, or here it is, render D3 and D3 output functions. So these are special, I can't type and talk at the same time. These are special functions that come with R2D3. So render D3, that just takes some argument that returns a D3 plot. And D3 output, that's just expecting some sort of output that is a D3 plot. So that's pretty straightforward. The other part that's like a little mysterious still here is where the selected model thing comes from, which is that text that tells you which model you've clicked on, which car you've clicked on. And yeah, because there's no input that you define anywhere saying this is what your selected model is. Instead, that's going to actually be in the JavaScript. And so I'm going to go ahead and look at that file. So this is a JavaScript file. Here I've got at the top, just in comments, there's kind of a reminder of all of the different variables that are getting passed in. And here I'm pulling out those options for what the X and Y variables are going to be, because if you'll notice here, I'm actually passing those in as a list. So that gets transformed into a JavaScript object. And I'm going to gloss a little bit over some of this D3 code because I know we haven't really gotten into that yet. I'll point out, oh yeah, here's where those transitions, if you want those smooth transitions, I've added these transition functions, which is another D3 feature. But here, so this little chunk here is where we're defining all of the points in that scatter plot. And essentially each of these, so this is, yeah, each of these is just adding another attribute to each point based on the data that it's related to. So each point is kind of bound to a specific datum. And at the end here, I add this on-click event. So this says, for each of these points, which is bound to a specific data point, when you click on it, call this function. And this is a function, this little d is the datum that that point is bound to. So that's like all the information basically in that row in the data table. And it's calling this function right here, Shiny set input value. So this is actually a function that comes with Shiny. And it just takes 2 arguments, the name of the input value and what you want to set it to right here. So that's how we're able to, when you click on that point, that's how it's able to set that selected model value. So yeah, super quick overview of what the Shiny app looks like. And just to look at it again, you know, here's our inputs. You update this, and it updates those X and Y values, which get passed into the D3 plot. And so then the data updates, and yeah, you get these nice little transitions. Oh yeah, I keep choosing the same thing. That's not a very exciting plot when the X and Y axes are the same. Cool, so yeah, that's what that looks like. So yeah, that's just a super quick kind of overview of some of the things you can do with R2D3. And let's see. Yeah, just kind of to summarize it, we've got the RStudio integration where you can create the new D3 script. It gives you a nice little template from the new file dropdown. You can do those previews, and then there's a couple of options for exporting it. And then, oh yeah, there's a couple different ways you can include it in your R Markdown. And then in Shiny, you've got those render D3 and D3 output functions, and then that special Shiny JavaScript function. And if you want to come back and look at like some of that materials that I went through, I've actually have it on GitHub, so feel free to take a look there. And I also just want to point out a couple places. We've got the R2D3 site. It has a gallery which has a few different examples of visualizations, and it actually includes the R code and the JavaScript code that you need to create it. And then here is the D3 gallery. So this is all of D3, not just R2D3. And I love coming here if I'm just looking for like any sort of inspiration for data visualization. I think there's a lot of really great examples. And again, all of these include the code that was used to create them. So I'm hoping that Jason has figured out how to present or at least get some audio. So we can go over to dive in a little bit into how D3 works.
Yes. All right. Can you hear me?
Yes.
Super. All right. So we couldn't get Jason to get onto this platform, so we're going to have to jump to a different platform.
All right.
Sorry about that, everyone, but we can do it. I just posted the link into the chat. I'll post it onto the Meetup site, and we'll wait a few minutes to give everybody an opportunity to hop on. It's completely open. It's just a website. It's meet.jit.si/Ellis_and_Jason. And everyone should be able to get there fairly easily. You don't have to, it's completely open. It's just a website. I promise there's nothing bad on there. So I'm going to stop sharing that and get all one big video. All
okay.
Right. I just heard that recording is on from a voice.
Yeah.
So let's get going.
Okay, so I'm going to go ahead and do a let's see here, a screen share.
So everyone, if Jason isn't the largest tile, you can just click on, hi Helen, you can just click on his tile in Jitsi and it should become the big, oh, there's me.
Yeah.
Become the biggest view.
Okay, so why D3? I'm assuming a lot of folks who, I mean, like as an analyst who you know, as you're working with a lot of data, and you're using things like ggplot2 and different, plotting engines, and you come to this like front page for D3, and it's just, you see all the really cool ways you can impress your friends, and you're looking at this stuff, and it's almost, it almost seems like with D3, it's like you're only limited by your imagination. The geospatial stuff is like outstanding, and this is one of my favorite ones, where you can see these geographic transformations on the fly, and with those transitions, and you can do scatter plots. So yeah, I have been wanting to I've been wanting to learn D3 for years, and I've had some false starts. There's been times that I picked up a project and it didn't quite stick, and so I'm going to help you all. Hopefully, I'm going to help you figure out what are some missing pieces to make this happen. So first of all, what is D3? Well, a short definition is D3 is a JavaScript library for building interactive data visualizations in the browser. You can see that. But I think a more specific or precise definition is D3 is a JavaScript-based API for interacting with the DOM that's focused on creating SVG elements with data. So there's some terms here. There's the DOM, we have SVG, we have JavaScript. I'm going to walk through what these things are. So D3 is a really steep learning curve. I tried to like pick it up and become fluent in it several times before I did. And what I have learned is that, and what I learned early on is that it's hard. D3 is hard in part because you have to understand the DOM. It's hard in part because you have to understand some HTML, some CSS, and very specifically SVG. And you have to work with these things using JavaScript. So what I hope to do is like explain these points to you. First of all, what is the DOM? It's an acronym, stands for Document Object Model. And there's a lot to say about it, but the thing I could say is that it's what your browser will build internally when it reads a website's source code. So your browser makes a request to a server, the server returns some CSS, some HTML, and a bunch of JavaScript, and then your browser reads that information and then constructs this model, this thing that it uses to render websites. And so that DOM is actually something that you can interact with on just about any page. So you can see we're back in the browser here. Let's go back to that D3 homepage here. And in any browser, you can open up something called developer tools. And so here's my developer tool window. And the key things I want to point out here are these first two tabs, the inspector and the console. So what the inspector is this is a representation of the DOM. And in here, I can actually look and pinpoint each one of these elements. And I can see in my inspector, these different items appear. And as I scroll over the items in the inspector, I can see them appear in the web page. And this DOMs are they're tree-like structures with a lot of nested components, and it has a root. And that root here is this HTML element. Well, no, the body. It's this body element. So here you go. You can unfold this, and this is all nested material. All of this is a combination of CSS and HTML, and there's some JavaScript in there too. So this is the inspector. Then the other part I want to show you is the console. Now, as data scientists, whether it be from Python or R, you know what a Python console is or an R console. This is a console just like those, except for this one interprets JavaScript. And so if I can do like var x equals 1, and then x plus 1 is 2. So this is just a JavaScript console. And in fact, it's even down here in the inspector as well. So here we can see the DOM, and we have a console, and these are the tools that we're going to use to work with the DOM. So we know what the DOM is. Now let's talk about what SVG is, or scalable vector graphics. So vector graphics, most of you all know, but I'll keep it brief. Vector graphics are a type of computer graphic that is described by the points and lines and polygons that make up that graphic, rather than the colored pixels that make up a graphic. So because you're storing a graphic as points, lines, and polygons, it's totally scalable. And so that's what, when we say scalable vector graphics, that's what we're talking about. But SVG in particular is like an XML type markup language, like HTML. But this one describes points, lines, and polygons. And so here is some SVG. And I will say that if you can draw points, lines, and polygons and squares, right, it makes sense that you could visualize data with this. And ultimately, this is what D3 is using to build visualizations in the DOM with data. And so let's just look at this SVG tag here. We have this parent tag that describes what it is, and then we have a tag that represents a rectangle. We have a rectangle that's positioned at 10 pixels, positioned at the 10th x and the 10th y pixel, and we have some width and height parameters that are associated with this rectangle and a fill color. We close that tag. Then we have a text tag, and this one says hello world. And what we can, and just to show you this actually works, we're going to go back into our browser here. I have a blank page. I'm going to close this guy and open up a new one. Blank page. Let's look at the inspector. We have body tag. That's cool. It's empty. If I go in here and I say edit as HTML and I paste this and I enter it, we have some scalable vector graphics, and they are indeed scalable. You know, some text and a pink square. So cool. So that's what SVG is. And I'll take this one brief moment to talk about this program called Inkscape. Inkscape is like the main free and open source vector graphic editor. And what's neat about Inkscape is it's actually like an interactive SVG writer. So when you're drawing things in Inkscape, what Inkscape is doing is writing SVG. And the files that you save from Inkscape are parsable text, just like this, just like we see here. So that's really neat. So we know what the DOM is, we know what SVG is and what that does in the DOM, but so where does JavaScript fit in? So JavaScript originally was a domain-specific language for interacting with the DOM, and it's grown so much since then. You can run web servers in JavaScript, but if you think about JavaScript as a language very specific for interacting with the DOM, then it sort of makes sense that you can interact. You can change websites and interact with websites in a programmatic fashion using JavaScript. And JavaScript has it's got a really bad rep, but I've actually come to like it quite a bit. It's a multi-paradigm language. This ECMAScript 6 spec that came out a few years back has a lot of functional programming in it. Our programmers love functional programming. And if you have any questions about trying to do something in JavaScript, someone's already asked it 10 times over on Stack Overflow. So in some ways it's an easy language to learn. So we know what the DOM is. It's this document object model, and we know that we can draw things with SVG in the DOM. So can't we just do data visualization with JavaScript and those two things, SVG inside the DOM? And in fact, you can. And so here's a big pile of JavaScript. And I'll walk us through this. We're going to assign some variables here, and we're going to build an array of random data. And right here, this JavaScript is saying, go to the document. This is the root node of the DOM. Go to the body element of the DOM and append to that this SVG tag. And we're going to assign that node to a variable, SVG. And then we're going to set some attributes to that node, height and width. And we're going to use the variable we assigned up here. And then we're going to iterate through our data array that we assigned up here, this array of random values. And we're going to iterate across that. And for every element, we're going to take its index and we're going to run this code. And what we're going to do is we're going to build out rectangles that are positioned at 5 and on the x and at some value at y that's determined by the index. We're going to set the height and width to our box variable that we assigned up top, a fill value, and we're going to append that rectangle that we're building here to our SVG element. And so we're going to do that for every element in the array. And let's do that. So if I just run this JavaScript, we haven't started working with D3 yet, a blank page. I'll dump this in the console. And cool, we have a bunch of rectangles that we positioned on the side there. They're squares, but they're rectangle tags. And what else can we do here? So document, this is the node, the root node, and we have this method for this node called query selector all. And what this does, this allows us to select nodes from the DOM. And we're going to select all the rectangles. And then for each one of those, we're going to run this function. And this function is going to set the attribute width to our value of data. So this is an array. We're looking at the index of our rectangles, and we're going to grab that index from our data object. So back over here, let's go ahead and just run this code now. Hey, cool. So now we have something that kind of looks like a bar chart. Right, there's no axes, there's no labels, but you can see just by building SVG using JavaScript, we can start to visualize arrays or different types of data. So what do we need D3 for? Well, D3 makes all of this so much easier and adds a lot of and does a lot of work for us that would be hard to do manually. This code here does the exact same thing, but it's far more readable. And there's one funny thing here, but we'll get to that. So we're going to assign these variables here, and we're going to go call D3. D3 is this, it's an object that has a bunch of methods. And we're going to call the select method. We're going to say select body, select the body node, append an SVG node, set that SVG node's height and width to a variable. And then this one's kind of hard to explain. This is like kind of the hardest thing of D3 newbies right here is this pattern. What this is saying is select all rectangles. Then that means select all of them, whether or not they're 0 or 50 or 100. Select them all. And then we say for all of those that, for all of these rectangles, anywhere between 0 to 100, we're going to apply this data. And for every element that is not on the page, we're going to add that element. And so when we run this the first time, there are no rectangles, but then we apply one for every element of data. And right here. And so what do we do for every one of these? We append a rectangle, we assign it an X coordinate, we assign it a Y coordinate that's determined by this index, and these other things too. Width is this attribute here, width, is a function, and that function runs for every element of data. And what does it do? It just returns that data. So we have a function here, data goes in, element 1, return that element. We know it's an array, so that's the value we want to apply to width. So I hope that makes sense. I don't know if I explained that well. Oops. So let's go ahead and refresh, and let's run this D3 code. And there it is. It's the same thing. Yep. Okay, and so what D3? So we know. So D3 is like making it easier to write these types of visualizations. You saw how much less code that was, and how much more readable it was. But what it also does is it keeps track of state. And so this would be something we would have had to have done manually. If I run this bit of code here, what this does is returns the data that's associated with this particular element. This bit of code here says go to the document node, grab all the rectangles, and then get the first one. And then that node has a bunch of properties associated with it, a lot of properties. Goes on and on and on. This node has so many properties. One of them is data, and D3 did that for us. So now when I'm working in this visualization and I need to know what data was assigned to this rectangle, I can do that. Okay, more D3. So now this is a much more complicated example, but this, what we're going to show you here is the enter, update, and exit paradigms. This is how you get data in and out of your page that might be changing due to interactivity. So we talked about enter. Well, let me back up and say that what this paradigm does is that the enter method is going to add elements to the page that don't exist. Update is going to change the elements on the page that do exist but have new data. And exit is going to remove elements on the page that no longer are supported by data. So if your array drops like 10 values, you should have 10 less elements. So exit's doing that for us. So we can read this code. We've seen all this before. We have this variable. This is the height and width of our SVG, the size of the box, and then our random data. And then this should look pretty familiar now. We have D3, select body, append SVG, assign this height and width value to the SVG element. And then we create this function called enter, and enter takes that SVG node that we assigned up here, adds all the rectangles to it, and with this enter method, appends those rectangles, and does this work that we've seen already, where it assigns the y value by index. And then we're going to add another function here. This on method is really cool. What this does is that for every one of these rectangles, we're going to add a mouse enter event. And that event is going to run this function every time our mouse enters that rectangle. And what it's going to do is it's going to reassign a new random set of data. And then it's going to run the enter function, the update, and the exit. So here's that enter function. This is not the same thing as the enter method that we assigned here, but I named them the same. It's probably not good practice, but I think it looks tidy. So what does this update function do? Update function goes to the SVG node, selects all the rectangles that are present there, applies the data, and sets the width of that element to the data, with the data value it's associated with. Exit selects all the rectangles, applies the data, uses this exit method, and then removes all of them that are no longer associated, that are no longer, there's no longer data for. And then, so these are just functions. They have to be run. I just run enter here, and it runs this with this mouse on event. And when the mouse on event happens, these get run. I hope that's clear. So let's see what this looks like. So now I should be able to mouse enter here, and they're changing. And as I move there, it's just generating new data, pulling rectangles off the page, adding new ones as needed, and updating ones that are there. Yeah, this function doesn't just make random data, it also makes a random number of elements too. Empty cars. So us R users are really familiar with empty cars. And I have an example somewhere here. Here we go. So I'm using this is an Emacs terminal here. This is a much more complicated example, but let's just take a quick look at it. Yeah, it's still scaled. Cool. So we have a scatter plot now, and it's like familiar data here. So how do we do that? Well, let's talk about what this is doing right here. We're reading in a CSV. Oh, that's nice. And but there's an extra thing happening here, and that is, and this is one of the most confusing things about JavaScript, and one of the things that I found so challenging about JavaScript when I was first learning it is that JavaScript works asynchronously. Often, anytime it makes an API call or a request to a server, it makes that request and then it moves along in the code. So it doesn't, by default, wait for things to return. So JavaScript has a lot of ways of dealing with that. Callback functions, set interval, async methods, and promises. This is a promise. What this does is this goes out to the web and grabs this CSV. And it's waiting for that data to come back. And then when it does, it runs this function here. And this function then will pass what was returned by this to this function. In this case, it's the data. What this D3 method also does is it takes our CSV and converts it into an object that JavaScript can work with. And that's it's like it's a JSON object. It's a nested named list. It's an array of objects. And so we pass that in, and we're going to do this D3 stuff again. We've seen all this before. We have something new here. We have scales. Scales are super interesting, and this is another really challenging thing about D3, and scales help us deal with that. So, big yawn.
Be sure to mute yourselves, everybody.
Sorry.
All good.
Yeah, it's fine. What we have here is a scale, and you're going to use these all the time when you're working with D3. What scales do, this is the point I want to make about this, is that when you're working with a lot of other data visualization software, you don't have to think about where things are plotting on the screen that often. That is to say that like you pass it some data and then it's going to map those data to the screen or to the page automatically. D3 is not going to do that for you. What if you tell this circle to go to this one location, it's going to go to that pixel location. It's not going to like look at your, if you pass it, for example, miles per gallon. We have miles per gallon between 10 and 30. And you said, go, put a circle within that range. It's going to put those on the page between the pixel ranges of 10 and 30. But you don't want that. You want it to plot with, like, in this area that you've defined that represents, the units of interest. So scales will help us do that. What they do is they map a range of values to another range of values. In this case, we're taking the minimum miles per gallon value and the maximum miles per gallon value, and we're applying it to a different range. In this case, is where I have the beginning of my margin and then the width minus that value. Width being the width that I want my plot to exist in. We do the same thing with Y. We take the min and the max of this horsepower variable, and we're mapping it to the height or the vertical space that I want those to appear on the screen. Another funny thing about D3, or about plotting anything in the browser at all, is that the coordinates are a bit backwards than what you'd expect. The coordinates work from, the origin is in the top left corner of the screen. And so when you map this horsepower variable, you have to map it from not like where you have to not map it from the bottom, but you have to map it from the top. So in this case, this height value minus my margin, height, right, or this 500 value. So it starts at 500 and then it goes to my margin, which is 50. So we take the min value of horsepower and map it to the max, the height of where I want this to plot at. I hope that's clear. So then we have this series of operations here. We take that SVG element, we're appending a group element to it. And SVG groups are part of the spec. They're a very important part of the spec. They allow you to group all these different types of vector graphics into nice containers that you can name, and then you can move groups and all of the different elements they contain as a single unit. You can translate them as a whole, so you don't have to translate every single circle. You can translate all the circles, and that's what we have here. We put a group. We call this call the group, give the ID dots. And then we do this pattern that we've talked about where we add all the circles here. We give them a fill color, black. We give them a location. The SVG spec describes, you describe a circle location using CX and CY rather than X and Y. And then we're giving it a radius of 5 pixels. One of the things I like about D3 is that because it is just writing SVG for you, you use this standard of graphics, this SVG standard. And when you want to figure out, like, how do I position this, like, this path or something, you oftentimes have to look at, well, how is this supposed to be written in SVG? And then you kind of figure out how is D3 doing that for you. So we've added a bunch of circles in this group dots. And what we also had in our plot were axes, on the bottom and on the sides there. And so D3 offers us methods to simplify that process for us. We have this method axis bottom and axis left. What these imply are not where they're going on the page, but rather where the ticks are located. Gotcha. Yeah, this is like it's not an axis on the bottom of the plot. It's an axis with ticks on the bottom of the axis. And what that takes is our scale. Remember, we defined a scale way up here, where here, this mapping of data values to pixels on the screen, it uses that as its input. And the same for the y-axis. This variable here is actually, it returns a function. And that function is used here. So we've got our dots plotting in a group. We have our axes that we've just built here. So SVG, we're going back to our SVG element. We're going to append another group. We're going to call it x-axis. And we're going to transform that x-axis. We're going to move it. We're going to translate it. This transform is a part of the SVG spec. It takes a value, many values. In this case, we're going to use the translate value. And this is, being built out programmatically with our variables that we're defining. We're going to do this call method right here. This works like it does in other languages, where it's actually taking this thing we just built and passing it to this function. So we use call as opposed to wrapping all of this in a function call here, because for pipelining, it makes it look clean. So we're making a group, we're transforming it, we're making the y-axis group, we're transforming it. And that's how we got this really basic plot here. And if we look, SVG, we have our dots group. I'm pointing to my inspector here. We have our dots group, we have our x-axis group, and our y-axis group. You can see it, that transform attribute has been applied with the translate value. And let's just take a moment and appreciate all the work D3 did for us, because if you can imagine having to describe every one of these little lines here and these numbers and where they plot and are they plotting alongside the data properly, D3 did all that work for us. Like coding this manually in JavaScript would be ridiculous. Or I don't know, maybe it's got to be good enough. Okay, so this is my last slide. The last thing I want to say about D3 is, that D3, is taking every data element and it's representing that by some SVG element, and you could see that if you had like thousands and thousands of points, all that stuff is going to be in the DOM. And then anytime you want to interact with this, the browser is going to have to like parse through this tree and get that item and change it. And if you had, if you're using big data, it would not be a good tool to use for that, specifically for like, some of the single cell visualizations that we see often. And so, yeah, D3 has its limitations. It's super fast until it just has too much. Well, there's a solution out there, and it's called HTML Canvas. HTML5 Canvas is a different approach to visualizing data, and instead of filing all of these vector elements in the DOM, what it does is it has a single tag, and that single tag is a canvas tag, and the canvas tag has a property, something called a context. Okay, and it uses that context to draw in the canvas. So it's one element, and the browser storing all that canvas information internally. It makes visualizing big data much more feasible, and it also can leverage the graphics card. And just to give you a demonstration of how powerful that is, here we go. Let's go to this link here. So Mike Bostock is the creator of D3, in case you didn't know. And what he did is he coded up Clifford attractors using Canvas. And you can see all of his code down here, and it leverages a lot of WebGL. What Clifford attractors are, they're like you're plotting like tens of millions of points in this recursive algorithm, and so what we're looking at here is the graphics card processing the tens of millions of points to make these shapes, and it's plotting those tens of millions of points. And this is just not something that's really feasible without using Canvas. So yeah, that's all I wanted to say about that. And then Helen showed you the D3.js stuff.
Wow, that's really cool.
Yeah.
Thanks for sharing that, Jason.
Oh, wow. A lot of people stayed. Good.
Yeah, thank you all for staying and sticking with us as we, dealt with the technical difficulties and whatnot. So yeah, thank you, Helen and Jason, for giving us these great presentations. I know I learned more. This is the second time I've heard it, and I learned more this time too. It's always interesting to hear more and more. As always, thank you for joining us. If you have any topics you'd like to see us present on, or if you'd like to give a presentation, please reach out to me on, just shoot me an email at ellishughes@live.com. or send me a message on Meetup, and we can try to make that happen. Thank you all for being here. All right, take care.
Thanks, everyone.